نحن على موعد الآن مع محاضرة رئيسية بعنوان الاستفادة من تعزيز السلامة الكهربائية في بيئة العمل، تطوير وتنفيذ وصيانة برنامج شامل للسلامة الكهربائية في أماكن العمل، يقدمه السيد روجر بريسدن، خبير سلامة معتمد من أرامكو السعودية في المملكة العربية السعودية، فليتفضل مشكورا. The floor is yours, sir.
Thank you very much. Appreciate it. Salam alaikum, and I'd like to thank everybody for the opportunity for me to come here today and add some value to this, what I think is a very important symposium. Anything that has to do with improving the lives of people is important. I've been in the health and safety field now for about 25 years, and it's really a passion of mine. Anyone who is in the field of health and safety that's not passionate about what they do should take up another job. I've had the pleasure to see a few of the speakers today, Ron in particular, talk very passionately about safety in the workplace and how his experience can enrich the lives of others. So today, I'm going to attempt to achieve three things. The first is I'm going to talk a little bit about the evolution of safety, and not in depth. I just want to put a few slides up to emphasize some points. Secondly, in terms of the conference theme, Safety of Power Supply System, Challenges and Solutions, when I was asked to put a paper together, I had an instant idea, and it relates to a previous employer that I had and a very significant challenge that we had, and an opportunity based on that challenge to improve health and safety, in particular around electrical safety. So the bulk of my presentation is going to be based on that process, the challenge we faced and how we overcame it. And I think that through that process might be able to add some value to what processes people are going through at this stage and give you some ideas on how you might be able to improve your program. I'm going to finish up my session with really just some kind of high-level thoughts on health and safety. And for those of us in the business of health and safety, after being involved in significant incidents, getting the phone call that says, "Sir, we need your help, there's been an accident," to those of us that have had to talk to spouses, children of workers that have been hurt and killed on the job, I consider that to be almost the dark side of my job. It's something we need to do, but safety professionals kind of take all of their experience and the lessons learned from each and every one of those incidents and try to make life better as we move forward. So I'm going to walk through this presentation, and I'm going to cover the following items on the agenda. I'm going to give a little bit of background where I talk about the evolution, and I'm going to focus my presentation on the development, implementation, and maintenance of a comprehensive electrical safety program. And I'm going to cover off some basic things. We're going to ask the question, why do I need an electrical safety program? How do I get started if I want to have an electrical safety program? What are the key components of an electrical safety program? What type of leadership should we expect? And how does leadership fit into the process? What are the various phases of going through the implementation of an electrical safety program? I'm going to touch on some key references, and we've talked about some of these today already, but I'll just highlight them again, and then I'll summarize my thoughts. So I'm going to start off talking about the evolution. This is some information I came upon, and it's out of the American Electrician's Handbook in 1953. So this is only a little over 60 years ago. And it's probably a bit hard for you to read, so I'll touch on a couple of key points here. The first one, 154. This is all around measuring, testing, and instrumentation. The first work instruction tells electricians, it says electricians often test circuits for the presence of voltage by touching the conductors with their fingers. This method is safe where the voltage does not exceed 250 and is often very convenient for locating a blown out fuse or for ascertaining whether or not the circuit is alive. Some men can endure the electric shock that results without discomfort, whereas others cannot. So, I think we've evolved a little bit. Let's look at 155. The presence of low voltages can be determined by tasting. The method is feasible only where the pressure is but a few volts and hence is used only in bell and signal work. Where the voltage is very low, the bared ends of the conductors constituting the two sides of the circuit are held a short distance apart on the tongue. If voltage is present, a peculiar mildly burning sensation results, which will never be forgotten after one has experienced it. Oh my, oh my. So I think the importance is, if you look at the last line says, care should be exercised to prevent the two conductor ends from touching each other at the tongue. For if they do, a spark can result that may burn. Okay, so this is where we used to be. This is the work instructions that were given to electricians back in 1953. So I've thrown a few statistics up just to show and demonstrate the evolution of safety. The slide on the left is a graph that shows by year, starting in 1980, the number of worker deaths by electrocution. And you can see the graph starts at about 600 per year. And then as we roll through the graph, 1980 to 1992, we see that that is significantly declining. The next graph starts at 1992 and carries on to 2010. And we can see in 2010 the number of fatalities have dropped down in between 150 and 200. So you can see that between 1953 and 1980 and 2010, that there has been a significant evolution in the process of safety. And that evolution has helped contribute to less fatalities by electrocution. So, in essence, we've come a long way, but we still have a long ways to go. Here's a few more statistics that I dug up from OSHA based on 2013. So it says that in 2013 there was 30,000 reported arc flash incidents. As a result of those 30,000, 7,000 burns were incurred, and out of those 7,000, 2,000 were severe enough that they required hospitalization. Out of those 30,000 incidents resulted in 400 fatalities. The interesting part of all of these statistics, I think, is that only 21% of those injuries and fatalities involve qualified workers. And in this definition, a qualified worker is really talking about an electrician. So the other 79%, if my math is correct, are workers other than qualified workers. These are roofers, these are landscapers, these are different types of tradespeople and laborers other than electricians. So what's happening? Really what's happening, and Ron touched on this morning, is that we in our organizations have safety cultures being developed. And as these safety cultures develop, many things are happening in the background. First of all, employees are becoming more aware. They're becoming better educated, and they're becoming more involved and participating in our health and safety processes. And we know it's a fact that if we can educate workers to the point where they understand health and safety, they will eventually buy into that process. They'll take ownership of the process, and as a safety professional, we can almost walk away and help them manage the health and safety process. And again, Ron talked about this morning that safety people don't own the program. And I agree with that 100%. We do play a very critical role in the educating, in the sales of health and safety, in customizing processes for people, but we really become enablers. And it's up to us to get people involved so that they take ownership. The other things that are happening is that programs that did not exist are being developed. Programs that did exist are being improved. And as a result of that, we see a decline in number of incidents, resulting in a decline of number of injuries, resulting in higher health and safety performance, resulting in better morale, resulting in a better business. Okay, so lots of things are happening in the background as our safety cultures develop. But one thing that we expect out of all of this is better safety performance. So we have less tolerance for risk. We want to see better programs and better processes for our people. Okay, so to take you to my particular challenge, in 2011, my role was the health and safety manager for a power generation company based out of Boston, Massachusetts. And I looked after approximately half of 32 power generating facilities. So my role in the field was to provide them with health and safety support. My role also doubled as a corporate safety person where I was developing policies, procedures, and in Western North America, Canada, and United States, I would take those policies, procedures out and effectively implement them in the field. And the one thing that we struggled with in that organization was a fragmented electrical safety program. We had many components of what I would call a health and safety program, but not a fully developed comprehensive program. And as we tried to figure out our way, we incurred a few unfortunate incidents. And luckily, very luckily, these were significant events that didn't result in significant loss, and especially loss to people. We lost some equipment, but we didn't lose any people, fortunately. And at that point, we decided we needed to escalate the process. So what we did was we decided to implement a comprehensive electrical safety program based on the current Canadian workplace electrical safety standard at that point in time, which was CSA Z462, the 2012 version. And so I just want to kind of take you down the path to the development of the electrical safety program and our experience. So when we looked, the first component was, our first thought was that we wanted to make sure that we took a management system approach. And if you look at the Wikipedia definition of management system, it'll tell you that it's a formal, structured approach that contains processes and procedures to help an organization get to an achieved outcome. And so that's what we decided to do. We decided to adopt a management system approach where we could look at the plan, do, check, act process and implement that as we went around. So the other thing that we needed to do was we needed some help. We were resource scarce. We had a HSE team of 6 people managing all of North America, all of these power plants, and only half of those people were safety. So we brought in an electrical safety expert, a gentleman out of Calgary, Alberta, named Terry Becker. And Terry Becker is he's a well-known electrical safety expert in Canada. He is a contributor to the CSA Z462 standard. He sits on the technical committee. He sits on many technical committees of IEEE and other organizations. And I think Terry's done a wonderful job in terms of developing a process. So I met Terry. We brought him on board as a consultant, and with Terry's guidance, we ended up going down this path. So we looked at the electrical safety program, and we said, what do we need to have in there? So we need it to become a toolbox of resources that can help us effectively manage our arc flash and shock hazards. So we need to outline our principles, we need to have our policies clearly outlined in there, and we need to have very specific practices outlined as well. We understood the importance of recognizing hazard and risk and implementing appropriate controls. And we've talked about hazard and risk a little bit this morning, but again, I want to emphasize, because what I see in the field quite often is there's not a really good understanding of the difference between hazard and risk. And if we think about hazards as being a physical entity or existence of an entity that could cause loss, and Ron talked about this morning, loss to people, loss to equipment, or loss of process. So it's the existence of a physical component that can cause harm. Secondly, when we look at risk, risk is really the exposure of people to that hazard. And we look at durations, and we look at the impact of the exposure should something go awry. Okay, so the difference between hazard and risk is very important. We needed to make sure our employees knew this. Defining roles and responsibilities. We knew that we needed to have a program champion, and we knew that that program champion had to be at the senior executive level. So what we did is we tapped the Senior Vice President of Operations. We sat down with him, and he was intimately involved in the challenges as well, so he was on board. But he became he took our sales efforts up the line to the Chief Executive Officer and helped us sell the program. The next thing we needed to do was identify key stakeholders. We wanted to make sure that everybody that was impacted by us developing an electrical safety program was actually part of the development process. And again, it's easier if we get people involved in the beginning rather than creating a process and trying to sell it to them after without gauging the impact on them themselves. So the next thing we did was we looked at performance measurement components. We said, how are we going to measure whether we're successful or not? So we created some key performance indicators. We wanted to make sure that our process was aligned with current standards, codes, and best practices. So we did that. We chose to align our process with the CSA Z462 standard. Our ESP required senior management demonstrated commitment. So we obtained the senior VP's backing, and we got a commitment from senior executive on the principle and the direction and the outcomes that we expected in our process. And then finally, we wanted to make sure that the scope covered all of our affected employees. Our business was generating electricity, and probably 50% of our employees were either qualified electrical workers, electricians, associate electrical workers, maybe apprentices, but the other 50% were not. But what we recognized was, as the other 50% went about their duties within our facilities, they were exposed to potential arc flash and shock hazards as well. So we wanted to make sure that we covered the non-qualified electrical worker components of the process as well. We wanted to make sure that we considered contractor safety. We took the stance that Contractor was just as important as anyone working on our facilities, and we made sure that any of their programs and processes were aligned with our electrical safety program. We prioritized the preventative and protective measures. We looked at the hazards and risks, and we said, what specific preventative and protective measures are we going to outline in our electrical safety program? We based those on risk assessments and using the hierarchy of control measures philosophy. We wanted to make sure we had a comprehensive task scope, so we wanted to understand every single task that our qualified electrical workers were undertaking, and we wanted to make sure that we built a procedure in there for safe work for every single one of those tasks. And out of these key components, we thought that collectively we had a pretty good chance of undertaking safe electrical work and making that environment safe for those working in and around energized electrical equipment. The final component that we wanted to consider was making sure that we had a continuous improvement process. How are we going to make sure that if we have a problem, we identify the cause of that problem, and we build the appropriate changes into our process to continue to make it better? Okay, let's ask ourselves some questions. Why do we need an electrical safety program? Well, first of all, it supports due diligence. Due diligence is defined as us as employers doing everything reasonably practicable to prevent loss, okay? And it's a very simple statement, but it's very hard to achieve. We need to make sure we have solid programs, processes, commitment, support, training, equipment, and on it goes. And we need to be in a position to say that although the incident happened, we did everything reasonably practicable to prevent it from happening. The next point I want to talk about is accountability and responsibilities. We wanted to make sure, this is related to why do I need an ESP, and it's really important because it does help outline who is accountable for what and who's responsible for what. From a general perspective, when you talk about responsibilities, we know that we're all responsible for safety. I heard a very poignant statement one time, and it really resonates with me, and I use it all the time. And somebody said, I wondered when somebody was going to do something about it, then I realized I was someone. So it really emphasizes the point that we are all responsible for safety. So we need to make sure that we have responsibility and accountability defined. We know that an electrical safety program will contribute to positive health and safety performance. We know that it'll reduce the likelihood of injuries and incidents, and all of the benefits that we get out of that, reducing the likelihood of injuries and incidents, controlling costs, improving morale. What an ESP will do will help you put an element of consistency across business lines. So if you have multiple business units, divisions in various countries, it really allows for no divergence from that process. And it really becomes a platform for ongoing effective management of electrical safety issues. So as an employer, we have the responsibility to manage electric-related hazards and risks. We can do that effectively using the hierarchy of control measures, so looking at elimination, substitution, then engineering controls, then administrative controls, and finally, personal protective equipment as a last line of defense. And why do we need to do all of this? Well, we have a moral obligation to our employees. And there's a couple of reasons why we have safety programs in our companies. One is because we want to make sure that we control costs and that on the profit and loss side that we're on the positive side. But the most important aspect is because we need to protect our people from loss. And that's why we do our jobs the way that we do. And I guess the other thing that I found is a lot of organizations, when they look at electrical safety, they do this from a disjointed perspective. They haven't moved very far along from having individual program components. Okay, so again, we can ask ourselves some questions. Do you have existing electrical safety hazards causing risk? Have you experienced loss as a result of incidents? What's your current level of confidence in your systems? And is there a desire to improve your health and safety performance? Okay, so having said that, how do we get started? Okay, we have to get organized. We have to consider this as a project. We need to gauge the organization's appetite to take this on, obtain senior management's commitment and support, and without that, we're going nowhere. So we were very successful at having the program champions sign on to the process at the beginning and support our roadmap for success. We assigned a project manager, and that person became the electrical safety program committee chairman, and that happened to be myself. And the next thing we did was we formed the electrical safety steering committee. And that steering committee was made up of the key stakeholders that I talked about. So a representative from operations, from maintenance, from technical services, from all of the major business lines that our process was about to touch. We went about conducting a gap analysis. We did audits of our electrical safety programs. We found out where the gaps were to help us again fill in our roadmap. And the other thing is we established some timelines and milestones. Here's a graphic that just shows some of the components that we made sure we built into the program. There's the hierarchy of control measures. We've got some personal protective equipment. We had risk assessment matrices. We had tables of arc flash hazard identification. We had incident energy analysis resulting in PPE and labeling requirements. So those are all key components. I just want to kind of go through a couple of the program components in a little bit more detail. And this is really each and every component from the policy, purpose, and scope that you see on the top left-hand side all the way through to the management of change process. And some of these are fairly obvious, so I won't spend a lot of time on them. The blue ones are all fairly obvious. When we get down to electrical system data, we wanted to make sure that we had a pretty good understanding of our entire electrical system. So we were looking at single line drawings in all of our facilities. We wanted to establish electrically safe work conditions. So we wanted to find out what do we need to do in every single one of our organizations to create these electrically safe work conditions. And this was really a statement about how we were going to conduct our work. And it takes into account when we're going to de-energize, the test before touch, all of these types of philosophies we built into the process. Power line safety, we looked at our overhead and underground lines. Operating fixed electrical equipment. So we looked at our components of all of our circuit breakers, all of our components within our environment, and how we were going to manage that fixed electrical equipment. We considered portable equipment and extension cords. So anytime we were bringing in portable generators, considering making sure that they met code, making sure that they were properly installed, that they were properly grounded. Temporary power distribution systems, same thing. If we're bringing in temporary power, looking at making sure we had a component that covered that. Electrically safe PPE, so looking at our arc flash clothing and our arc flash suits, looking at our equipment and tools for electrical work, so any of the other technology, we looked at remote racking devices. And we pulled all of these components together and we created really a comprehensive document that outlined each and every component. The training part was very important. We worked with Terry Becker to create 2 mandatory online training courses for our for our people. Qualified electrical workers were required to go through a 7-hour online training course, very, very comprehensive. And if anybody is looking for comprehensive online training, I definitely have the person I can steer you towards. So qualified electrical workers did a 7-hour. Non-qualified workers were required to go through a 45-minute awareness online training session. But again, fairly comprehensive, that related to working in and around energized electrical equipment. So we set our priorities for maintenance and housekeeping, for safety by design, how we were going to purchase our equipment, how we were going to put it into the process. We beefed up our emergency response procedures, particularly focused around electrical incidents and fires. We created an audit process where we would audit the entire program on a regular basis, and we made sure that we identified how we were going to manage change. If we were changing out components that would impact the program, how we would manage that change. So this diagram shows a little bit about our leadership structure. So again, we had the program champion at the top, the electrical safety program manager, who also chaired the steering committee, and all of the various business lines that were included in that electrical safety steering committee. Let's look at the project phases. There was really 4 phases. In phase 1, I'll go through these fairly quickly. We assigned the project leader. We obtained the management commitment. We identified who those stakeholders were that we wanted to participate. We formed our committee. We confirmed our objectives. And we moved forward. Second phase, we decided on the program components using the system, management system approach. We made sure that there was alignment with other processes within our organization. And we reviewed feedback. We obtained management approval, and we rolled out the program. And then the 4th phase was gathering feedback and continuing to improve the process. So a couple of slides on references. There's our CSA standard and the NFPA 70E. This was another very important document that has just recently been developed out by the Oil and Gas Commission in Canada and provides very good guidance. And if anybody's interested in looking at that, I can steer them the right way. We created some really good graphics with Terry Becker on boundaries for arc flash and shock. And so in summary, really the result is electrical injuries usually are a low frequency, but the consequences of them occurring are fairly high. When we look at the fact that you haven't had any injuries or any injury history, it really doesn't mean that you have an effective electrical safety program in place. And the other thing is to realize is half of the electrical fatalities are qualified electrical workers, the other half are not. Okay, and in summary, these are the various components that we focused on, making sure our people were trained, we had enough resources, sufficient time, that we had budget, that we had a proper structure, and that we had the proper systems in place to create this culture, to create the program. And I'm getting the time's up nod. So I would like to say thank you very much for letting me talk about my challenge and my solutions, and I look forward to any questions you may have later on. Thank you.
Actually, no. Let's have the Q&A.